The animal of the day, May 26th, is the extinct Palaeochiropteryx. Type: bat. Diet class: insectivore. Average lifespan: estimated to be up to 10 years. Size: up to 4 inches or 10 centimeters in body length. Wingspan: up to 10 inches or 25 centimeters. Weight: up to 0.4 ounces or 10 grams. Population status currently May 26, 2025, extinct. Population estimate: none, extinct. Native lands: Central Europe. Primary habitat: subtropical to warm temperate forested environments near lakes or freshwater bodies. Main predators: small carnivorous mammals, other early mammals, birds of prey, and snakes. Diel activity: likely nocturnal. Species age: emerged approximately 48 million years ago, and extinction likely occurred at the end of the Eocene epoch. Notes: the Palaeochiropteryx is an extinct genus of bat from the Middle Eocene epoch of Europe. The Palaeochiropteryx genus contains two recognized species, Palaeochiropterygidae tupaiodon, which is the type species, and Palaeochiropteryx spiegeli, both of which were found from the famous Messel pit of Germany in 1917, and they have not been found anywhere else. And an additional but highly debated and unrecognized dubious species, Palaeochiropteryx sambuceus, was found from the Sheep Pass Formation in Nevada, United States. Fossils of the Palaeochiropteryx genus are usually found complete and exceptionally preserved, even retaining the outlines of their fur, ears, and wing membranes. The Palaeochiropteryx genus is one of the oldest bats known from complete skeletons, and despite their assumed primitivity, they were actually quite advanced, already showing evidence of echolocation like modern insectivorous bats. There are two major reasons why the discovery of the Palaeochiropteryx genus is of importance and value. 1. This discovery alters perceived relationships among extant forms at a few poorly supported nodes. And 2. The newly found fossils affect some character polarities and also change the levels at which transformations appear to apply. The Palaeochiropteryx was surprisingly very similar to modern bats despite their relative age, with the wings having been formed from enlarged hands, even though their wings were less advanced than modern bats, like how they still possessed a claw in the index finger. Both Palaeochiropteryx species, tupaiodon and spiegeli, were small bats, with spiegeli being slightly larger and heavier than tupaiodon. Analysis of melanosomes preserved in the hairs of Palaeochiropteryx specimens suggest that they contained pheomelanin, which would have given the species a brown color in life similar to modern bat species. The small bodies of Palaeochiropteryx, along with their relatively broad wingspan, suggest that they may have been low-level flyers, like some modern bats with the same body structure. The Palaeochiropteryx would have been specialized in hunting close to the ground beneath the jungle canopy and among vegetation, unlike other bats found in Messel pit, which flew at higher altitudes. The Palaeochiropteryx had low wing loading and low aspect ratios, suggesting that they were relatively slow flyers but were able to maneuver in midair quickly, essentially avoiding collisions with numerous obstacles near the forest floor, which may have made them vulnerable to the poisonous gases of the former Messel lake, which would explain the abundance of their fossils. The shape of the Palaeochiropteryx's teeth and stomach contents indicate that they were insectivores, with tupaiodon feeding almost exclusively on moths of the Microlepidopter family, while spiegeli consumed caddisflies in addition to moths. From the results of radiographic analysis, Palaeochiropteryx, as well as other related fossils, all have enlarged cochlea relative to the size of their skulls, which is what is responsible for hearing. Unlike most other fossil bats, Palaeochiropteryx, along with Eukaryota, Archaeonycterus, and Hashaniceterus, have not been referred to any extant family or superfamily, and since these Eocene taxa are known from exceptionally well-preserved fossils, They have long formed a basis for reconstructing the early evolutionary history of Chiroptera bats. In 1977, vertebrate paleontologist Thierry Smith suggested that these taxa represent an extinct clade of early microchiropterans, which he dubbed Palaeochiropterygidae. In 1979, evolutionary biologist and paleontologist Lee Van Valen argued that these fossil forms are representative of Eukaryota, a primitive grade ancestral to both Eukaryota and Microchiroptera, or fruit bats and carnivorous bats. However, modern researchers consider this clade obsolete and is no longer used. In 1987, vertebrate paleontologist Michael J. Novacek reanalyzed the morphology of Eukaryota and Palaeochiropteryx and concluded that they are more closely related to Microchiroptera than to Megachiroptera. Most recently, in 1998, mammologist Nancy B. Simmons and vertebrate paleontologist John A. Geisler found that Eukaryota, Archaeonycterus, Haseonycterus, and Palaeochiropteryx represent a series of consecutive sister taxa to extant Microchiropteran bats.